Thank you, Eric, and thank you everyone for coming tonight. And I'm going to jump right into our talk. And I have to learn, there's my screen down there. I've been interested in scientific imagery ever since I've been a historian of science. But it wasn't until fairly recently that I realized that scientific illustration in the early modern period, which is roughly the 17th century, sometimes into the 18th, that scientific illustration of that period is missing a certain kind of image, which we kind of take for granted. I call it the image of, or the visual record. That is a picture which captures a discovery or a person or an event or a landscape. It really doesn't much matter. But it's the kind of thing we see in popular science books today. And I realized that they're not there. From about 1600 to about 1660, well, there are a few, but these are exceptional ones. That kind of picture isn't there. So what I'm going to do this evening is to talk about what was before this period when they were there, and then what happens to them, and maybe venture a guess as to why they disappear. Then we're going to talk about a brief period in around 1665 when suddenly we get images that are visual records, real pictures of real things, and then they disappear again, and they don't really come back into the literature until almost into the 19th century. So we won't be able to talk about the latter part very much, but we can talk about what came first and then what happened in the 17th century, and that will be my focus. So basically, early modern is just the term we use when we talk about the period of Galileo and Newton and Descartes. You see these representatives up here on the screen. And it doesn't need to be taken rigidly. We use the term Renaissance for what came before, basically up to 1600, and then early modern, and then modern. So it's just kind of loose terms that we don't really need to worry about too much. Now, in the Renaissance, roughly the period from whenever you want to start it up until 1600, we find lots of informative images that are, in many cases, images of record and images that record information. We see here just kind of an odd selection. I'm going to talk about some of these books in particular. These are images from Vesalius. We'll talk about him. There's a natural history book at the bottom full of pictures of real animals. Star atlases we won't talk about at all, but they're certainly pretty, so I stuck one in there. So as an example of a book that contains images that contain information that you can use to supplement the text, so what I mean when I talk about a visual record. I'm going to show you very briefly some pages from George Agricola's De Re Metallica, 1556. You'll see at the bottom of this slide it says History of Science Collection, Linda Hall Library. I'm not going to put that up again because every other book you're going to see is from the collection here. So we have a fantastic rare book collection. Everything is going to be from it that I talk about. The only thing that is not are a few emblem books which we do not collect. So Agricola's De Re Metallica, it's a very famous book in the history of science, large, about this big. It has numerous, almost half-page woodcuts that show every aspect you'd want to know about mining, metallurgy in many cases. And these are rich images. When you think that printed imagery really began like 100 years earlier than this, not even that much, it's kind of amazing to find pictures, for example, the one on your left there, which shows a mine shaft and some pumps working. You see that's a cutaway. So actually this is cut into the thing so you can see through and see what's happening in the mine there. That has to be invented. And it was invented sometime before, but it's already in use here in Agricola's book. And the one on the right is a similar. I'm just going to go ahead and show you a close-up of those two pictures. So you can see the use of cutaway. They have very quickly learned how to do exploded diagrams, where you take a machine, you just take it apart and leave the parts around so you can see what goes into it. That's pretty sophisticated. Leonardo did that, but not many people did that afterwards. So already they're using fairly sophisticated images in this book of 1556. Some of you are probably aware of this book, very famous work. Ordinarily we wouldn't collect a book like this because we're not a medical library, but this is such a famous book in the history of printing that we have it. Vesalius' De Fabrica of 1543. And here we encounter hundreds of woodcuts. They show us Vesalius. That's not common yet. They show us skeletons. They show us muscle men. There's even a image in there of Vesalius at work, as I call it. He's actually down there in the trenches. see him there kind of in the middle. He's got this giant woman, this 7-foot cadaver that he's cutting up for his class, which is a new kind of a thing to be doing in anatomy. So it's very rich images in this work, and again, considering its early date, 1543. This is a book published a little later, but still in the Renaissance, Domenico Fontana's book on moving the Vatican obelisk. How many people have been to the Vatican and seen the big obelisk that's in the center of St. Peter's Square? So we got quite a few here. Well, that wasn't always there. It was about 300 feet away for many years, over near the Vatican itself. And the Pope, I think it was Sixtus V or Fiftus VI, whichever one of those, decided that we need to move it. So they hired an engineer to move it, and he did so. You moved it 400 feet. The Romans moved it like 1,000 miles when they put it there in the first place. But still, it was considered to be a great engineering event, and it's documented in this book in a wonderful manner. You see the little picture on the left that shows them lowering the obelisk from its original position and all the machinery they used. And then they have to build a ramp and move it to the new position in the center of the square. The square, by the way, wasn't there. Bernini is in the future, so they hadn't really designed the square yet, but they had the centerpiece. And now you see another picture of their lowering it again, and then an aerial view. That's pretty nice. Aerial view of the capstans they used to raise and lower the obelisk. So a pretty sophisticated book, a beautiful book. Again, it's a large work. So in the Renaissance period, we have images that are pretty sophisticated, and as I say, they convey drama. We got dramatic pictures. It's very exciting because the Fontana book is a sequence, so you can follow the story. It's kind of like a YouTube video, only it's a series of stills, but they use the image to tell the story, and it does so very effectively. In natural history, I don't have time to show you very much, but I did want to make the point that there are a whole spate of natural history books that come out in the 1550s by Conrad Gessner, and in this case, Pierre Bellone. And practically always, particularly so with Bellone, they make a point right on the title page of saying that the pictures in here are true pictures. They're the real pictures, the real thing. And on the sturgeon there on the right, he's got the caption that says, "A true picture of a sturgeon." So they try to make the point that we want to show the real animal, the real thing, not some copy of some medieval manuscript as was done before. I think this is my final Renaissance example. Even physics, which is not very pictorial in most places, even in physics books, we see things like this. This is a book in our collection that shows what was thought to be the trajectory of a projectile, which was, according to Aristotle, it goes like this, and then it goes like this. And it's not correct, but the pictures are great. They show, and that really is my point. Well, we get into the early modern period, into the 17th century, and again, this is the period of Descartes and Galileo and Kepler and a great number of people. When we start looking through their books, we don't find pictures like we found in the Renaissance books. I can think of, in fact, that's how I made this slide, I thought of things that I'd like to see pictures of that are important 17th century events. So Galileo discovers the law of falling bodies by rolling balls down planes. So that's not very exciting, but it'd be a nice picture, right? Newton does a very famous experiment where he sends light through a prism, and then he takes some of the light, the red light, and sends it through another prism, and it doesn't change anymore. So he's trying to establish the white light is made of colors, and once you break down the colors, they don't change. So it's so famous that it's called the crucial experiment. So I'd like to see a picture of that. Let me go back one. This is my back button. Yeah. We'll show a picture of this later. So Otto von Guericke did a famous experiment in which he took a couple hemispheres, put them together, took all the air out with an air pump, and then teams of horses couldn't pull them apart. So it demonstrates the weight of the vacuum. Very pictorial experiment, right? You want to see a picture of that. I want to see a picture of that. Pierre Gassendi dropped a ball from the mast of a moving ship, because Galileo had said, but he didn't do the experiment, that if you did so, the ball would fall at the foot of the mast because it would share in the inertia of the moving ship. So he actually did it to see if, in fact, it falls at the foot of the mast, and it did. So that was a pretty famous experiment. I put Francis Bacon's death in there just because it was so pictorial. Bacon supposedly, according to his secretary anyway, stopped his carriage one night to go buy a chicken from a woman merchant there and stuff it with snow to see if the snow would preserve the chicken. And he caught pneumonia and died. So that's that's kind of, I'd like to see a picture of that someplace. And then the last one on my list here is Blaise Pascal, a famous mathematician, but also a pretty good physicist, who did an experiment called the Puy de Dôme experiment. And this one I'm going to explain, and I'm going to use an image to explain it. So, very famous. It's again, one of the half a dozen most famous experiments of the 17th century. And what happened just a few years before, 4 years before, it had been discovered by a man named Torricelli that if you took a glass tube, closed at one end, filled it up with mercury, and turned it upside down in a bowl of mercury, the mercury fell to about 30 inches, a level of 30 inches, and it didn't fall anymore. So that was very mysterious. What kept the mercury up in the tube? What was in the top of the tube, where it fell? So it raised a lot of questions, a famous experiment in its own right. But what Pascal did is he said, well, if the air, he said, let me go back one. So Torricelli proposed that what keeps the mercury up in the tube is the weight of the atmosphere. So the air pushes down on the mercury pushes up on the mercury in the tube, and they balance. So the atmosphere must weigh as much as 30 inches of mercury. That's Torricelli's suggestion. Pascal wanted to test this. He agreed with it, but he wanted to test it. So he talked to his brother-in-law, and his brother-in-law agreed to take a Torricellian tube. This is what we would now call a barometer, but that's not what it was used for then. So take a Torricellian tube and climb to the top of the Puy de Dôme, the big mountain in central France, and see if the mercury goes down in the tube. A wonderful experiment, right? And he does that experiment, and he finds that the mercury falls to about half its previous level. So it's a perfect experiment designed to test the conclusion, and it turns out that it supports the conclusion. So it's very famous. So you'd think there'd be a picture of this, right? Well, there is a picture. You're looking at it. This picture, however, is from 1868. This is the first time, as far as I can determine, that the Puy de Dôme experiment is recorded as a visual image. And that was shocking to me, that not only that Pascal didn't do it, but that no one later did it in the 17th century, nobody in the 18th century, not until the last part of the 19th century do we get a picture. So what do we get if we look in some of these books? For example, this is Galileo's work called The Two New Sciences. It's his work in physics. Not the Copernican book, that's the other one. So this is usually called the Discourses, the Two Discourses. And this is a book about the breaking moment of beams, what happens if you overload a beam, where will it break, for example, things like that. And in fact, there are two nice pictures in this book that show beams that have been loaded down. I'm not sure these record a Galilean experiment. I can't imagine him finding in the Tuscan countryside some ruins like this to attach his beam to, but they're kind of nice pictures. But that's it in the book for what we would call, visual record. This isn't a visual record of anything Galileo did. It's just a nice picture. It's put in there because it's attractive. Galileo reveals in this book that a projectile moves in a parabola. There's the picture you get in the book. So it's a nice parabola, but it's a diagram, right? It's not a picture. There is no image like we got in Sandbeck in the physics book of the Renaissance that shows you an actual gun firing something and to see what happens. Galileo discovers that if you shoot a projectile off a cliff, like this way, that its inertia takes it this way at a constant rate, and its tendency to fall is an acceleration. It goes down, and the result is another parabola like that. So it's a wonderful discovery. This is the picture that we've got of it. And so there's nothing else in this book that you would call, really a picture, except for those two ruins with the beams on them. So this is our contrast. This is what we would find in the Renaissance. So here we have an invalid theory with a nice picture. For Galileo, we have a valid theory with no picture. This is another one of those half dozen famous experiments. I alluded to it once already, where Newton takes light and sends it through a prism and then breaks it down into its colors, and then breaks one of the colors, tries to break one of the colors down further, and can't do it. This is Newton's own drawing. So he made a picture of this. And this drawing still survives. I think it's at Cambridge. And when he publishes his paper, this is what we get for a picture of this. So it's a line diagram. And it's just this is in the Philosophical Transactions, where he publishes this very famous experiment, and yet you would hardly call this a visual image of record. Nicola Steno, a lot of you might not have heard of him. He's really, in my mind, as important as Galileo or Pascal Kepler, but he works in the field of geology and paleontology. He really reformed both of those fields. In fact, he started them both, to be really honest. The book on the left is a book on fossil shark's teeth. It's actually a book on muscle anatomy, to which is appended a little treatise on shark's teeth. The one on the right is called On a Solid Within a Solid. It's about stratigraphy. In fact, it founds the science of stratigraphy. So these are very, very important works. We have two really nice copies in our collection. So if you look in the book on shark's teeth, you get this. Now, those are pretty nice. That looks like a visual record. That's a shark. I forgot to tell you, the way Steno gets interested in shark's teeth is that the Duke gave him a shark. It washed up on shore. It was just the head. So he dissected it. He was an anatomist. And he saw the teeth, and he knew that fossil collectors had these things on the right that they called tongue stones, glossopetra in Latin. And Steno compares the teeth in the shark's mouth with the fossilized teeth on the right and comes to the conclusion that, well, they're the same thing, really. One's turned to stone and one isn't, but clearly the things on the right had their origin in the mouth on the left. This is a great set of visual records, but it's not Steno's. When he wanted a picture, he went into the Vatican Library, and he found from 1580, he found a couple of copper plates that was made by a former librarian, and that's what these are. These are a century-old pictures, not of Steno's shark, some other shark, and not his tungstone, some other tungstone. So apparently it didn't matter to Steno that the things he was illustrating were not his. And I think that's generally the case, again, up until about the time this book was published. There's his other picture from his other book, The Strata of Florence. You can hardly see it here. It's a very important discovery that Florence was originally a bunch of horizontal strata, and that forces of water caused it to collapse, and some things to get tilted, and then they built up new strata on it. So it's a whole geological history of Florence here, but it's done in a diagrammatical style. There's no picture of the real strata of Florence, what it looks like if you went along the Arno River and kind of looked at the hillside. So this is the pictures that we get in this really milestone book. René Descartes comes the closest, sort of the great natural philosophers, to putting interesting pictures in his book, but they're not still the kind of pictures I was looking for. That is, visual image pictures that record an event or a discovery. These are his two most famous books. We have them both. The one on the left is his Discourse on Method, where he thinks, and therefore he is. And the one on the right is the Principles of Philosophy, which is his book on natural philosophy, his counterpart to Newton's later book on the Principia. So I'll show you some pictures from both. So Descartes discovers how a rainbow works. He discovers that a raindrop kind of bends the light around and bends it back to the viewer. And so it's a very important work. The picture is kind of nice, but it's a diagram, right? You see a big drop up there at the top. He's magnified that so you can see the light passing through it. And then it's got a little figure down there at the bottom, but you would never call this a picture, I don't think. And on the right is again, I'll call it a diagram of the vortices that Descartes believed made up the universe. Each sun, he thought, was the center of a vortex of swirling matter, and each of those things that you see as a little labeled dot is a sun or a star. One's a sun, and the rest are all stars. So it's nice, but it's not a picture of the universe, and he doesn't really intend it to be so. In some cases, he's kind of whimsical. So for the law of refraction, he's got a little tennis player standing on a bank there and showing that the light bends as it comes out of the water. And then the one on the right shows the fact that if you have a ball in a sling and you whirl it around, the ball doesn't want to be in that sling, and if you let go, it goes in a straight line. So he's demonstrating the principle of what we call rectilinear inertia in a kind of a whimsical way. So again, that's kind of nice, but again, it's not a kind of an image of record. Now, to kind of make a transition, I want to show you a book that does have pictures in it, but to show you that they're different from the pictures that we have encountered. This is a work by a Dutchman who was a Cartesian, which means he adored Descartes, he followed Descartes at any rate. And his book is it's like an annotated Principia by Descartes, and it's got we aren't going to talk about frontispieces today, but you see it's got a nice one there. But he's got a little section on the principle of inertia that Descartes talks about and gives us a little picture of a sling there. I'll blow that up. So that's a wonderful picture. It shows people with a battering ram knocking down a door. Well, the reason you can knock down a door with a battering ram is because the ram has inertia, right? So you get it going at a certain speed, and it's going to knock the door down. but it's not a picture of anything Descartes did. It's, we'll talk about in a second about what kind of picture this is, but it's not an explicit picture of Descartes discovering the principle of inertia. Descartes was kind of well known in a bad sense for his laws of impact. He tried to figure out in every case what happens when a big ball runs into a little ball. And in some cases they'll stick, and in some cases one will bounce off, and he tries to figure out how much motion each will have. So this is an illustration of Descartes' laws of impact using cannons. So you got two cannons firing bluntly right at each other, and Descartes does predict, well, they'll stop. If they're the same mass, they will, and have the same motion, they will stop. Whereas two balls that are different size and traveling with separate velocities, if you put them together, they'll travel on, but they'll have a lower velocity than they had to begin with. So he's illustrating it, but he's not illustrating. It's not a picture of anything Descartes ever did. We'll skip this one. It just shows you to illustrate the angle of reflection. They're equal, the angles of a bounce like this. He has a couple of tennis players. Descartes is very fond of tennis, apparently. And then that one, well, I'll explain this one. Descartes thought that the universe was made of three kinds of matter. There was the matter we see when we look around in this room, the big matter, so he calls that third matter. There is the matter that fills the spaces between all the third matter. We don't see it, but it's got to be there. And so there's these little balls, boules he calls them. And so you imagine a universe with big chunks and then little tiny round chunks, and then there are spaces between the tiny round chunks, right? So something has to fill them up. And that's the first matter, and those are the little odd-shaped pieces that are lying there on the surface. So Descartes never pictures these in this way. This is kind of a nice picture to demonstrate what Descartes' three principles of matter are. So these are different images from the ones we've encountered so far. I call these, for lack of a better word, really, emblematic images, which is, and I use that term to refer to images that are not visual records. They don't capture a particular experiment or a place or a person or whatever. They intend rather to teach a lesson about something using metaphors or allegories or analogies, or in some cases, emblems themselves. So emblematic images are very popular in the 17th century. We're going to talk about why, but they're kind of the antithesis of the visual record, of a picture that you can learn from about an experiment or about a law, about a demonstration. So a real emblematic image, where the word comes from, is from an emblem. Now, we've kind of lost touch with emblem books, but in the Renaissance and 17th century, these were very popular things. An emblem, I was going to show you what an emblem is. We have one emblem book, and we shouldn't have any because they're mostly political emblems or love emblems or whatever, but this is a book with animal emblems in it. And so we have this one book, and so I could take its picture. Now, an emblem is a convention, but it's got a certain, it's a genre, really, and there are certain rules about a true emblem. This is one that we don't have from a political emblem book, but an emblem basically has a picture in the center, in this case, a nice peacock, and then it's got a motto at the top, and then it's got some sort of a poem at the bottom. Usually sometimes in Greek or something you can't read, often in verse, but still, it's an explanation. If you can't figure out what this thing means, then you turn to the thing at the bottom. Well, this particular emblem is one of my favorites. We have a peacock, and the peacock is looking at its feet. Now, according to Pliny, this is what the bottom part tells you. According to Pliny, peacocks don't look at their feet because they have very ugly feet. So peacocks walk around like this, and their tail, they strut around with their tails up, and you never see a peacock like this because it's ashamed of its feet. So that's a story from Pliny, and then, so it's pictured here, you get the motto, and then it's got this wonderful motto at the top, know thyself, nasce te ipsum. And the point is that your feet are ugly, learn who you are, look at your feet. And so this is an emblem about that, and you can use this emblem in a variety of ways if you wanted to make the point that you should come to terms with your own self, and this is one of the best ones that there was. This is another one that we don't have. This is a political emblem. I want to use it just to show you how you use an emblem, if you're a scientist, for example. So this political emblem from a book by German Zinkgraf, it shows a Earth, and then it shows the sun in the zodiac, and then it has a motto at the top, and the motto means, thus with its rays, and it's intended as an emblem for a king, So the king illuminates all things. So the sun, this is how the sun makes its presence known in the world by its radiation. So it's a nice little emblem. If you look at this book in our collection, which is an astronomy book from 1632 by a man named Landsberg, he has taken that emblem and he's put it on his title page there at the bottom. I'm going to show you a close-up so you can see it. And what he did with this emblem is he turned it inside out. So he took the sun out of the zodiac and put it in the middle, and he put the earth in the zodiac, and then his motto says, in this way it illuminates all things. So he's a Copernican. So he's an advocate for the sun-centered system and putting the earth in motion, and he uses an old emblem to make this point emblematically. So it's a wonderful emblematic image. It is on the title page, and we're not going to talk much too much about title pages, except here's one. Francis Bacon, in his book, The Novum Organum, the New Organon, has on the frontispiece, has pictures of two columns, and there's a ship either sailing out or in. There's a debate about that. But anyway, that's it. It's a wonderful thing. Well, he expects you to know, if you look at his book, that there is an emblem for the Emperor Charles V that consisted of two columns. These represent the Pillars of Hercules. So this is the boundary of the Mediterranean, the boundary of the known world. And then there's a motto in this case, plus ultra, which means go further. You can go further. In the old world, it used to be thought that the world ended with the edge of the Mediterranean, and Charles, who's, after all, the patron of many great voyages like Magellan's, Charles says, we can go further. There is no limit. And Bacon expects you to know that because he's arguing that in his book. There's no limit to what science can do. We can go further, too. We can go out through the intellectual pillars and discover a new world. So emblems are very popular on title pages and frontispieces. We've talked about the last of those. That's kind of a separate subject. But they do creep into scientific books in the form of headpieces. So this is how emblems and emblematic images kind of get into the books. This is the first book of a work on optics that we have by a Jesuit, Francois Aguilon. It's called Six Books on Optics, which I've translated all these titles so you can read them. 1613, so fairly early on. And here's a detail of that headpiece that we saw for Book 1. Now, these are wonderful images, as they ought to be, because these were designed by Peter Paul Rubens. Okay, so no mean artist has kind of worked these out, and they're all delightful. You can spend lots of time looking for it. In this case, the first book is about the eye. They're dissecting an eye. Because they only have one eye, there's a Cyclops lying down who donated the eye. You see him down there at the bottom. So they killed the Cyclops, they took his eye out, and now they're dissecting it. These, I forgot to mention, the workers here, we call them putti. A puto is a little cherub-like thing, usually not an angel, although sometimes they look like angels, but they're often called upon to do work for whoever's designing a book. And in this case, they're industriously dissecting an eye and looking for advice from the one human in there, the one philosopher. So they're just wonderful images, and there's 6 of them, 6 Rubens originals in our copy. This is one where they're measuring the height of the Colossus of Rhodes using an optical method. So it's from that chapter. And there's another one, this is book 5. One of the things Aguilon is trying to teach is that if you have 2 candles, he wants to know if you have 2 candles, how far away do you have to move them from one candle in order that the illumination be the same? He's trying to discover the law of radiation. In fact, it was discovered then. And so these little putti are sliding these candles back and forth, trying to make 2 equal-sized dots there. So those are the wonderful headpieces. They're all engraved. I mean, they're very beautifully done. For text illustrations, we got this. I mean, there are others in there. There's some pictures of the eye. This is actually a very famous diagram because it shows the relationships of colors and how you can blend yellow and green, and get blue, things like that, although it's all in Latin. But it's not a picture, right? It is a diagram and not too exciting a one. We look at later books on optics. You'd think optics books would have great pictures. At least I thought so. This is Christoph Scheiner's, another Jesuit, and this is his book on the eye. And the frontispiece, which you see there, is full of emblematic meanings and proverbs. I won't point them all out, there are too many, but the guy at the upper right is saying, the eye is worth nothing without the hand. He's trying to make the point that you need both your hands and your eyes. He's got no arms and all these tools are lying around and he can't use them. So there's the emblematic part of this work. But when you look in the book itself, and I leaf through every page of this book, these are the images that you get. There are no pictures. Nothing that we would call a picture, certainly nothing recording a particular discovery. So this is generally the case for most 17th century books up until the 1660s. The big exception is the moon. So we got good images of the moon. And if you think about it, as I'm certain you are, you realize that there's a reason for this. This is Galileo's Starry Messenger, or as I should say now, this is from our first copy of Galileo's Starry Messenger. We now have two of them. These are pictures drawn by Galileo with watercolors at the telescope and then printed about 3 months later in his Starry Messenger. And this is a visual record. This is the kind of image I was talking about. It's a picture of something you observed, and it records kind of the time when you observed it, and there's nothing emblematic really about it at all. Well, as I say, you don't have to think about this too long to realize that it had to be a visual image because the discovery is an image, right? And the discovery is that when you look through the telescope, you see this big picture of the moon. So you can't record it without drawing the picture. And so we find lots of good pictures of the moon as seen through the telescope. We got lots of moon books. I'll just show you two of them to show you not everybody is a great artist, but that's not the point. Francesco Fontana, who wrote really kind of the second moon book, comes out in 1645, but he begins observing in 1629. And so he's got pictures of various stages of the moon, various phases of the moon. You probably can't see it from where you are, but up there at the top there's a little engraved text, and it says on 31st of October 1929, observed by FF, Francesco Fontana in Naples. So not only does he record what he saw, but he records the time. Well, that's a more sophisticated kind of a record, one where you kind of date stamp it. You know, this is when I saw this, and this is what I saw. And that's a very useful kind of a record, you would think. All right. Our final moon book, just to show that people recognize this, the value of the image when they're talking about the moon. This is Johannes Hevelius' Selenographia, which is kind of the most illustrious of all the moon maps of the moon atlases of the 17th century, and there is one of his moon maps. But what I want to show you are these lunar phase plates. It's got like 30 plates in there that each show a particular phase of the moon. No one had ever done that. Fontana has a couple of phases in there, but each of these is kind of a full-page plate. And on each of these, there is a little record at the top engraved in the plate. And this one I show you here, that this was observed February the 17th, 1644, at Gdansk. Okay, so that's where I saw it. That's what it looked like. And it's a wonderful, perfect kind of a very visual record. So the moon is an exception. Another exception is this picture here. This doesn't fit in anything I say, but I got to show it to you because it does exist. Christoph Scheiner, the same guy who wrote that book on the eye, in 1626 began publishing his book on sunspots called the Rosa Ursina, the Rose of the Ursine family, honoring his patron. And about 150 pages into that book, there is a frontispiece, very misplaced for a frontispiece to be sitting in the middle of the book, but that's what it is. And so you see here the whole frontispiece. The top of it is kind of interesting, but it's very Renaissance. I mean, it just shows you a bunch of people with instruments looking in different directions and measuring altitudes and things like that, which is nice, but it's not the part that interests me about this. But at the bottom, you see there a picture of the author, Scheiner, and one of his Jesuit colleagues at work. So they've got a telescope, it's pointing at the sun, they're using the telescope to cast an image on the piece of paper, and then they're drawing the sunspots. This is a way to record sunspots. Scheiner, we know he's in this, we assume he's the one sitting there, because he's the boss, sitting there writing things down, and the assistant is doing the work. So that's a wonderful kind of an image. I call this a scientist at work kind of an image. Did I put that in here? Yeah. I kind of collect these. I mean, every time I see a scientist at work, I always thought it would be kind of a nice course to do. But all my scientists at work are from the 19th century. And they're very popular then. You see geologists with their hammers, and you see astronomers with their telescopes and all sorts of things. You hardly find them in the 17th century, and this is one of the best ones. And so if we had a lot more of these, then I guess I wouldn't be giving this talk tonight. But this is the one that we have. And to build on that, images of any kind that are really documenting an event or a discovery are very scarce up until the 1670s. So why is that? Well, you're probably expecting me to answer that. And I wish I could. I have some suspicions, but I'll just present the one that comes to me because of my education in emblematic literature. I think it's because the emblem had kind of cornered the pictorial market. So the title pages are full of pictures that all have emblematic meanings. They're there for a purpose. The headpieces of people like Aguilon, these have further meanings. And the idea of a picture without a motto just doesn't seem to occur to anybody. That you could have a picture that just serves as a document instead of one that serves as kind of a game where you try and guess what these things mean. I'm sure there's more to it than that, but it is a fact that the emblematic tradition kind of begins to die out about mid-century, and we do find the images changing. And so I'm guessing there's a connection of some sort, but we can't document it. Nobody says, I'm not putting any pictures in my book because those emblem guys have cornered the market. If they did, I wouldn't have to have a suspicion anymore. So I've used exception twice, so it's losing its power, but there's a final exception. In this case, this is an entire book, and this is, I guess this is not really an exception, it is the prelude to what's going to come in the 1670s. So Ole Worm was a Danish antiquarian and a scientist and a collector, and of quite great note in his own time. In 1655, which is just after he died, he published a description of his museum. He had a museum, what they called back then, let me find it. Oh, there's a portrait. I didn't put portraits in of anybody else. He deserves one because of this book. So the book starts with this wonderful engraving of his Wunderkammer, of his cabinet of curiosities. There are lots of books published between 1600 and, in this case, 1655, that show wonder rooms. It's kind of a genre in itself. We have a lot of these here in the library. But in most cases, they don't show the real wonder room. They're just kind of like stylized images. They practically always have a crocodile hanging from the ceiling, and a big ostrich egg will be over here. And so they're generic kind of pictures. And the things they sometimes describe the real objects they have, but they hardly illustrate them. We have good reason to think that this is what Worm's museum looked like, that he had someone take a picture of it because of the references he makes to it in the text and other reasons that scholars have come up with. But what is really nice about this book is that he has some objects that have been stuffed and put in his museum that he had while they were alive, and he likes to talk about them. So he's got this, for example, this is a picture. He calls this a coati. It's not a coati, it's a raccoon. It's like the first picture ever of a raccoon, but nobody knows what a raccoon is. But what is special about this picture is that it's a picture of his raccoon, or his coati, as he would call it, his raccoon. You can't, I don't think I transcribed this for you, but it says down there just under, it says, I was given this coati in 1649 in the month of July in Amsterdam, and he tells you the doctor who gave it to him. And so it's this is his coati. This is not some generic coati that he got out of some other book. And there were lots of places he could have gotten pictures, but this isn't one of them. Here's his great auk. Very famous picture because it gets copied so much later on, but this is the first time it appears. Here I put in a little piece of the text and I'm going to translate it for you. So he says, this bird was brought to me from the Faroe Islands and lived in my house for several months. So it was my bird. It was alive. It's like the coati. I didn't mention that his coati, he kept it and fed it. He noted that it would get its food and would wash it, his food before it would eat it, just like a raccoon does, but nobody knew that, but he did because he observed it. And so this was the auk that he had, and he says, I had my bird drawn from life so that the image would be more accurate. So he's concerned that the picture looked like the actual bird that he had. And hardly anybody else is taking such concern over images. And this doesn't look like the most interesting picture, but I find it to be the most interesting. This is he had in his museum a piece of a tree, it's about this big, and it had grown around a horse jaw, the lower jaw of a horse. So a horse died, the jaw lay there, the sapling grew up and it grew around it, and eventually it kind of looked like this. So he's very proud to have this, and he gives us a picture of it here. I blow it up a little bit. You see the jaw and the thing there, and he says in the text, he says, it was given to me by King Frederick III on February the 6th, 1649. He goes on and talks a little bit more about it. But what intrigues me about this is that, before I get to that, in his museum, this is one of the pieces of evidence that his museum was a real museum. If you look in the back, you can't see the big thing, but you can see the little object there. I put a little circle around it. He's got that in his museum. He's got that little tree with a horse jaw in it as part of his museum. So it is his museum that's being portrayed. Well, the thing still exists. So you can go to the Natural History Museum of Denmark, and there the thing is. The woman in this picture is a former fellow here at the library, Katie Kendig. And she nicely, when I asked her, I heard she was going to Copenhagen, I said, would you take me a picture of the tree branch? And she did. She went and found it and took this picture. And so there's his image in the book, and there's the real object. So if that's not a visual record, I don't know what is. So visual records are very desirable, you would think, and they can add a lot to the text. They can talk back and forth between one another, but you just don't see them, except for Worm. So after about 1665, the situation changes for a little while. What have I got here? I got enough time. So one thing that changes it is Ole Worm. I mean, his book is very popular. As I said, there are lots of museum books, but this is a different kind with its emphasis on showing you the objects he has, not generic kinds of objects, specific objects. The emblematic worldview begins to erode. Now, this is a very complex subject. I wrote a whole paper on this very long time ago. But basically, up until about 1650, if you bought a natural history book, it had animals in it, and then it had emblems, and it had mottos, and it had coins, and it had all sorts of stuff. So natural history kind of came with a baggage of emblematics. And after 1650, that just goes away. The emblem books continue, but they don't put them in natural history books anymore. And so I think the demise of that belief that you've got to enrich anything you've got with mottos and classical allusions and all that, since that disappears, it makes it more possible to use an image that doesn't have an emblematic meaning. A new desire for establishing authority and for verification of empirical discoveries. This is a very controversial kind of a topic. I have to mention it, but I'll do it so in the course of this image here. Robert Boyle invents his air pump in 1660, publishes a book on it with a picture on it. That's kind of nice. It's sort of a visual record, except there's nobody in it and there's nothing happening, but still it's a picture of his air pump. But there's a lot of controversy in the first 2 or 3 years of air pump studies in England with what I call here establishing authority. And people argued, what is in the vase when you take all the air out? Descartes would say, well, there's still first matter in there and probably second matter in there. And then people like Pascal would say, well, there's nothing in there. It's a vacuum. It's empty. And so they argued about this. And so to establish their own theory, they took to invoking authority of, say, witnesses. So if you had 10 people stand around and watched you do an experiment, and some of them were earls and some of them were dukes, then if they said it happened, then it probably happened the way it is. So this is a very serious controversy, the question of visual authority and of witnessing, as it's called. So that probably has something to play here, because a visual record is a witness, right? It kind of records something that you said happened, and it can be a testament. So you'd think there'd be more visual images, visual records, if people are trying to establish authority. But the big thing is Robert Hooke. All by himself, Robert Hooke is going to show the power of an image as a visual record, as a document of what he has done. He does so twice, 2 books, both of which we have here in our collections. The most famous is the Micrographia, pronounced both ways. Probably one of them is correct, but I use them both. And we have a beautiful copy of this here. And what he does, he makes his own microscope. He doesn't invent it. Galileo invented the microscope, but he never did anything with it. Other people use it between then and 1660 when Hooke starts using it. But what he does is he'll just take something and he'll set it up and he'll just record what he sees. Now, this is not very glamorous. Thyme seeds. So he's got these little seeds of the herb thyme, and he draws a picture of them. And then to superimpose the text on it, he says, these pretty fruits here represent in the 18th scheme, that's his 18th engraving, are nothing else but 9 several seeds of thyme, 9 of them. They are all of them in different posture, both to the eye and the light. I won't read any more, but he points out that B is like an orange, and C is like a lemon. And this one has a bit of stalk on it, and this one doesn't. It's like they're his children. that he's describing here. And it's very clear that this is an image of what he saw. This isn't a generic picture. This is exactly what he saw. And because he had great artistic ability, it's what he was able to draw. I show you this just because I love this phrase in the second paragraph there. The grain affords a very pretty object for the microscope, namely a dish of lemons placed in a very little room. So that's his description of his little tiny seeds. I've always liked that. This is a plate that shows a silverfish and a tick and a mite. I'm going to show you his text about this. He drew all these, by the way. He didn't engrave them, but he could. But he drew all these, and in this case, he's got this thing that he calls a crab-like insect, which is a mite. And here's how he starts his discussion. Reading one day in September, I chanced to observe a very small creature creep over the book I was reading, very slowly, having a microscope by me, which a lot of people could not say in 1663. I observed it to be such and such. And then he goes on and he talks about CC. He's got these claws like a lobster. And then he's got AA. He's got these other smaller claws that are very sharp. So his text and his image waffle back and forth, but he's clearly talking about this insect here and describing it to the best of his ability. So he goes on through, like, I forget how many plates there are in here, but over 30 plates in here. Here is the louse. I won't detail you on this because most people were not happy to discover what a louse looked like. This plate is about this big. And so you open this book up, and if you've never seen a louse this way, it's quite a shock, considering that, of course, in the 1660s, you would have had these all over you. And so to realize that this is what's on you would have been somewhat disturbing. He even shows us in his book his microscope. Now, it's not dramatic. It could be more dramatic. It could show him at the microscope. That would be nice. But at least he shows you the instrument that he used. So this is a brand new kind of a book where every image is a visual record of something that Robert Hooke saw. And it's very powerful. And it's powerful because of the way that the images are used. He wrote another book. Actually, the book comes out a lot later. He gave another talk in 1668, which is called A Discourse on Earthquakes. And he got paid as a lecturer, a Cutlerian lecturer. And so in these lectures, he showed images that he'd drawn. And he's concerned with fossils. And the fossils you find in England, unlike in Florence, where Stella was, are mostly ammonites, the ones you easily find. These are big things, these big shell-shaped objects. So he finds these ammonites, and he collects them, and he draws them, and he comes to the conclusion, just like Steno did, that these are things that were formerly living creatures. And if you find them in a rock, it means they died, and they got covered with sediment, and somehow you have to explain that. But there's no doubt they were once living things. They didn't grow in the rock like this. Okay? They were once in the sea, and then they got transformed into rock by, must be a convoluted process. So these are the ammonites that he draws. And notice the one kind of in the center on the right, that particular one. I'm not sure what the exact year was, but it's in the 21st century, not all that long ago. They discovered in the Natural History Museum in London, they discovered one of the ammonites that Hooke drew. So it's the thing on the right, and all the ones except for the one in the upper left. The one in the upper left is his drawing. The other ones are all pictures of the real thing. And you see, he was serious about this. He really did draw these. He didn't borrow them from anybody. He didn't embellish them. He attempted to make them true representations of what he had found. So Hooke's, both his microscope things and his ammonites, they are visual records in every sense of the word. You really couldn't ask for anything more in an image. Some people pick up on this. I'll give you just one example here. Walter Charlton, who's a member of the Royal Society and knew Hooke, he publishes a book on zoology. It's not an encyclopedia. It's just a short book on a variety of birds. And this is his bee eater, a merops bee eater. And I just wanted to quote for you the text. So it's a great engraving. But he says in his text, the effigy, the picture, was commissioned from an artist, a sculptor he calls it, so that it seems to be a true bird and not an engraved copy. This is the bird I saw, the one I described in the text, and I got an artist and I had him draw it so you would know that was the case. He describes a hoopie, which is kind of like the blue jay of Europe, and he says of this hoopie was killed last winter 10 miles from London. I always like that. Like that identifies it, 10 miles from London, and given to me. I have added its effigy by a very skilled sculptor. So some people are taking up on Hooke and trying to represent the things that they write about with images that are of the very things they're writing about. And Charlton was one. And perhaps the best example of this, and this provided the images for our announcements here, Claude Perrault was a physician, a member of the French Academy of Sciences. And he published it first in 1671, and then he expanded it in 1676. We have the expanded version, which we're happy to have here in our library. This is essentially a book on comparative anatomy. So when the king had a zoo, a menagerie, and so when an animal died, they sent it over to the academy and they would dissect it. And since animals in king zoos are usually exotic, then you've got all these exotic animals. So here's, for example, one of the pictures of a chameleon, and you see the anatomical information there at the top. Well, one of the animals they dissect is a coati. And there's a little picture at the top that shows you some of its internal organs, but I'll blow up the bottom because that's what is of interest to us. So there's a coati. Now, coatis were not new. Two very good naturalists, had observed coatis and had drawn them. The one on the left is new to us, and we're not going to linger on it, but George Markgraf was a keen observer of Brazil, and he saw a coati, and he drew it, and he published it in 1648. And then Ole Worm thought he had a coati, but it wasn't. It was a raccoon. But still, they both published pictures of it, and they're both very reputable. And in both pictures, the tail is pointed up, because they said that's what they say. That's how it moves. So here's what Perot says in his text. The tail is bent downwards because it was disposed that way in the dead animal. Authors say, nevertheless, that the coati is accustomed to carrying its tail very erect. So how about that? He's got this dead animal on the table. The picture he draws shows what he's looking at, the dead animal. Even though he knows that it walked around with his tail up, that wouldn't be a picture of what he's dissecting. What he's dissecting is this. So it's kind of remarkable. I've never seen anything else quite like that, by someone demanding that the picture show exactly what you're discussing and that you not restore it, bring it to life really in any way. Well, as a result of Perot and Hooke and these people, this is where now we're kind of, all this is in between 1665 and about 1672. Does the nature of images change? Do we find this kind of spilling out? Well, in the short run, you might say yes. So, for example, we finally get a picture of the Magdeburg experiment in 1672. Von Guericke, the guy who did the experiment, finally wrote a book about it, and it's a great picture. It shows the horse teams and the hemispheres that are glued together only by the weight of the atmosphere, and it's one of the most picturesque scientific experiments of all time, and it's nice that we finally have a picture. The experiment was done about 25 years earlier than this, so it's not exactly current, but at least we've got a picture. Francis Willoughby, if I'm correct, I think he might be in your exhibit. It might be coming up. You might see this book. But his 3 books of ornithology, he solicits pictures from lots of people. And one of the people he asked for pictures of birds is Thomas Brown, who was an antiquarian and a naturalist and a beautiful writer. And Brown sends his pictures, and there's the 2 of them that he sends, the razor-billed auk and the guillemot at the bottom. They're dead. I mean, everyone else would draw a picture and they would bring the animal back to life, but Brown says, when I drew them, they were dead, and I didn't attempt to bring them back to life. So this is kind of taking Perot at his word. And if you go on through the end of the century, you'll find occasional pictures that are visual records. This is Thomas Savery, who invented a kind of a steam pump for pumping water for use by fire engines, and to pumping out of a mine. He gives you a fold-out picture. This is in the Philosophical Transactions of the Royal Society. And even you look at a tiny detail, you see people at work. These are scientists at work. They would go on my list. They are on my list of people that are doing this. But in many cases, nothing happens. Nothing changes. The first picture I've ever found of actual strata, where you go out and you diagram the strata of a particular area, which is so common in the 19th century. Every book has dozens of these. The first one I've ever found is from 1716 by Johann Schweitzer, actually by his brother, and it records a place in Switzerland where there are these 6 mountains kind of ring the lake, the Erner See, and he's tried to draw in what the strata look like. So that's almost 50 years after Steno's little diagrams. So nothing is changing very fast. Headpieces are still kind of illustrations of choice, particularly in France. They love the headpiece. So, for example, this is Picard did a treatise on geodesy, measuring the Earth. This is fairly early, but the one picture in there is a headpiece, and it shows people actually using a theodolite. So they're actually, it is an image of record here, but it's confined to a headpiece. Very famous book on Hydra. Those little tiny things that if you cut them in half, they will each grow back. You do this in high school biology. So the guy who discovered this is Abraham Tremblay. In his memoirs on polyps, which are hydra, all the illustrations, not true. Most of the illustrations in there are headpieces. They're informative, but they're clearly in the emblematic vein rather than being in the visual record vein. We get a kind of a brief spurt in pictorial images in the 1750s when electricity becomes a very popular subject and people start making generators. Then they start hanging little boys from cords and electrifying them and hanging women and kissing them and doing all sorts of things. These are just made for pictures. And so we find a lot of pictorial images of electro works in the 1750s and 1760s, but it doesn't extend out to other kinds, really, of experimental science. I'm skipping over some other kinds of books that change things. For example, all the voyages of Cook and others, they come back with real pictures, and they publish these in their book, scenes, you know. And then the Encyclopédie of Diderot, the famous French encyclopedia, is full of plates. They're not really visual records. They're just kind of drawings of equipment and things. But still, it's a very important influence. But the big book, in my mind, that changes how people view what an image can do is the Description de Egypt done by Napoleon's scientist that he took to Egypt in 1797. And so this first volume comes out in 1809, and it's got, like, I forget the number, 830-something engravings in there. And they illustrate everything. So they show, for example, there's Napoleon, by the way, on that horse there. They show measuring the height of the Sphinx. They show layouts of all the different tombs that they discover. They show ibis mummies that they dig out and they line them up and they draw pictures of them. There are pictures of everything. And this work again demonstrates, I think, more than any other kind of a book, what you can do with the right image. That the image can record stuff that you can't even talk about in your text. And it's kind of a perfect blending of text and image. So by the 19th century, we find lots of images being used in books that show scenes, but we have to wait a long time for that. So poor Perot's Coati, he makes such a smash in 1672, and he has to wait for over 130 years to really find any offspring, which is too bad. That's it. Thank you very much.
Right, if you have questions for Professor Ashworth, raise your hand. I'll come by with the microphone. We'll start in the front row here.
Hi there, my name's Eric.
Are you in your assigned seat?
Yeah, that's right. I have two questions. One, thinking about Aldrovandi, from Bologna in the 1640s, wondering if you would consider his big compendia in this vein or still sort of emblematic?
Very emblematic.
Okay.
He dies in like 1603, so these are all kind of posthumous things.
Right.
But it's not just the pictures are emblematic, but every emblem of, for example, in his work on, say, on four-footed animals, every animal that has an emblem is in Aldrovandi. I mean, you can find the whole emblem in there. You find everything in our emblem book. You can find everyone in Aldrovandi. So he's very much a part of the emblematic age. And he believes that a book of natural history should have all that in it, or it's not complete, which everybody believed in until about 1650.
And then my second question, which is sort of obliquely related, is whether we see the same sort of trajectory in fine art that's happening in these books over those centuries, that like very emblematic Renaissance paintings moving to a record?
Yeah, that's an excellent question. The historian of art, Svetlana Alpers was her name, I think, long ago pointed out, that long ago, pointed out that there's a difference between classical Italian painting and Dutch painting. And so the Italians are painting these classical works, and they are not paying much attention to detail of, say, what your room looks like. Whereas the Dutch, you kind of invent this kind of art, still life art, where you want to draw something as accurately as possible. So if that had percolated into scientific books, I think we'd have something there. So we have good pictures by artists of scientists doing things, For example, Vermeer makes a painting of Leeuwenhoek, looking at, we think it's Leeuwenhoek, looking at a globe, and it's a great picture, but it's never in a book, So as far as printed images go, there doesn't seem to be an influx from the world of art into the, even though Rubens does, those are great, that's a rare kind of a thing.
I should give a welcome to our online audience. We have a very large virtual attendance tonight, and let me get an online question from Stephen, who asked, are there any key cases of scientific literature being censored on the basis of the illustrations alone, as opposed to being a controversial theory as a whole?
That's an excellent question, which I have no answer to. I haven't really thought about that. The answer, I can't answer it. I don't know of any, but that doesn't mean that there aren't any. So I have to kind of look into that. So sorry, Stephen.
All right, we have a question here at the back of the room.
Oh, thank you for your talk.
Hey.
Hey, good to see you again. I'm wondering here if, I know I've done a lot of your work on sloths. Clusius in 1605, he draws a sloth, which he says he gets from a ship in Amsterdam. Do you think that fits in the older style, more of Gessner? And then also, is there maybe some formality that is starting in the 17th century that you don't see in the 16th, that now that they have all of these discoveries already, that may be a reason for this?
Well, I'm not sure about the second question, but I can answer the first. I think he's referring to a man named Carolus Lecluse, or Clusius, as he's called, and he publishes a book in 1605 called Exotica, and it's just pictures of animals that you don't find in Aldrovandi and these other books. And one of the things he shows is a sloth, and he says he got the sloth, got the skin actually, from a merchant, and so he gives us a picture of it. And so in his case, I think he's trying to show what he got, even though it's not a great picture. He's trying to show what he got. But the interesting thing is that everybody else who writes about the sloth for the next 50 years uses his picture, right? So his picture becomes the emblem, becomes the emblem for later sloth writers. And I think that's generally the case. All this innovation we saw in the 16th century with all these new animals being drawn, you can find those exact same woodcuts up through the end of the 17th century. It's only when an animal is new that you've got to do a new picture. If it's an old animal, you never draw it. People don't.
All right, hang on here. Let me cut across here. Dr. Sklar.
You started the talk, you showed really an engineering picture of moving the obelisk, but there weren't very many pictures like that. It would seem to me that there would be a lot of illustrations of engineering and architectural feats that were occurring during the same period of time to document them. How does that fit into all this?
Well, it doesn't fit because there weren't any. You're right. There ought to be. There ought to be more pictures like Fontana, more books like Fontana, but there aren't. We have lots of architectural books, but they show they show facades and they show ground plans, and they don't show anybody doing anything. And there probably are. There has to be other books besides Fontana, but I've run across a lot of books in my days of doing this, and I've never seen them. So if everybody does find a book that shows them transporting something, then I'd love to know about it, because I don't pretend to know every book that was put together. I wish I did.
Well, Bill, here's an online question about other books that you know. Could you mention at least a couple of other books which depict Cabinet of Curiosities, such as Ole Worm's Museum?
Yes, well, Imperato would be the first. We have a second edition of that. That's like 1599 or 1600, one of the two. There's a guy named Cerruti, that in 1622 publishes an emblem book a museum book that we have. It's got a folding plate in it. A guy named Basil Bessler publishes a wonderful engraving. I'd stuck it in if I could show you, because it shows him in it, showing people around, but just that it wasn't a real picture. It wasn't really him, but it's a portrait of him. Cerruti, Bessler, Worm, Imperato, and then there's a couple of the 1670s. Those are the ones I can think of off the top of my head from the early part of the century. But there are more, and we have them.
All right, we've got a question from some guy here in the back of the room.
I refuse to answer.
Thank you so much for the talk. I was curious about, after seeing how the sun emblem was repurposed and sort of, to my reading at least, kind of a dig at the royal figure, saying that we're going to take your royal use of this sun and turn it into a scientific use. Is there any validity to maybe a supposition that the lack of emblems is due to seeing them as tacky or gauche, not something a serious scientist would do, but instead something that emblems were for fancy pantses and not people doing the real science?
The answer is no.
Okay.
Yeah, I mean, there isn't. There might be in the 19th century, you might see that kind of a reaction, but nobody thinks emblems are silly, really. The question is, do they belong in a book of science? And after 1650 or so, they decide, well, no, they belong in their own books. They get an emblem book, but they're not looking down on them. They're actually a wonderful genre. I mean, you can do a lot with an emblem to make a point. And Louis XIV, for example, has got his own sun emblem. It's like the one we showed you here. And so he's the one who's illuminating all things, the king in the sky. No, nobody's ashamed of emblems or thinks that they're silly. At least nobody that I've looked at. Are you in charge of the clock?
Yeah, we're all right.
Okay.
Any other questions? Where's Brad? Brad, do you have a question? No? Okay. Let's end with a question from an online viewer. I mean, I might mispronounce your name, Tabata, who's an art and science historian, and would like to thank Dr. Ashworth for the fascinating and excellent lecture.
Both of those.
Could you?
This is some question.
Did you? Let me read this here.
Let me pace.
Did you find any evidence of the tremendous amount of time it must have taken to delineate these types of diagrams?
That would be applied to diagrams in general, I'm sure.
Yeah.
No, I don't. I mean, those kind of records may exist. I mean, Hevelius, for example, that we showed his movie, he did all those drawings. He did all the engravings. He printed the book. I mean, so amazing. And it takes an incredible amount of time. But how much time it takes, maybe he says someplace, maybe others say, but I don't know. It'd be very nice to know that.
So he was drawing them as he was looking?
Not really. I mean, he's drawing
Through the
stuff
top.
as he was looking. Then he would make finished paintings, and then he would engrave them himself, which is unusual. Both Hooke and Hevelius were engravers as well, and it probably helps in your artistic eye to know that you're going to have to turn that into a copper plate. Yeah, to know that.
That's going to survive for hundreds of years.
Yeah, that's right. Yeah, I don't think they knew that.
Well, thank you, Professor Ashworth, for just a wonderful talk.
And thank you for being a great audience. I enjoyed this.
Yeah, thank you for attending tonight's program. And as a reminder, our new exhibition, Chained to the Sky, The Science of Birds, Past and Future, will open November 10th. So we hope to see you all here for that. Thank you, and be careful out there.